Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I do have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. Useful links will also be shared in the chat. Which brings us to today's session. I'm so sorry. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Now, which brings us to today's session. The session will run approximately 1 hour with questions throughout, and I'll now turn it over to the speakers for introductions.
Awesome. Thank you very much. Whoa. Good morning, good afternoon, good evening. Welcome everybody to this session, Unpacking the Tech Behind Microsoft Build. So today is all about looking back over Microsoft Build, the rather cool developer conference that we had a couple of weeks ago, and kind of digging into some of our favorite bits of tech. This is one of a number of sessions that we're running at the Microsoft Reactor this week and next, where we just have a bit of fun talking about some of the cool tech that was announced at Build. Today, we've got a really, really cool session. You know, it's time to dig out all your metaverse hardware, put all your silly things on your head and talk about the metaverse and how we can bring it into our IoT solution. And I'm super excited. I'm joined by two fantastic people today, Riley and Alex. So Riley, do you want to introduce yourself?
Absolutely. Thank you so much for having us, Jim. My name is Riley. I am a PM with the Azure Digital Twins team. Been here almost 3 years and been working especially on the UX side. So from the ADT Explorer to now the 3D Scene Studio and other kind of developer / kind of end user focused experiences. So yeah, a lot of fun stuff to talk about here.
Cool. Alex, do you want to say hello? Introduce yourself. Alex, you're muted.
Yeah, so I generally start calls muted. So my name's Alex Hayward. I work at Microsoft as well, but I work in more of a customer-facing division. So I use digital day to day to try and help solve problems around in the manufacturing and energy space, and generally try and do innovation on it.
Awesome. Cool. Thank you very much. So Riley, I'm going to have to dig into a couple of things that you said. You dropped a couple of acronyms there, and I know it's something that a lot of big corporations is terrible about. You dropped terms like ADT and 3D scenes and things like that. And you mentioned digital twins. So for any folks who are watching who haven't come across digital twins, what is a digital twin? You know, is it like a robot version of me? Or when we talk about digital twins, what exactly are you talking about here?
Absolutely. And yeah, we do get stuck into kind of expecting people to know what we're talking about here. So that's really good to dig into. Azure Digital Twins is a cloud service, kind of part of the Azure IoT suite of products that is really geared around creating a digital representation of your business environments in the cloud. So what that digital representation means, at least for Azure Digital Twins, is kind of a graph database understanding or modeling of these live telemetry streams, whatever they're coming from your business world. So as until recently, Azure Digital Twins, or rather those digital twins, were really just the graph representations, the properties, the nodes, the edges that show the your business world and as it relates to each other. But with this kind of 3D Scenes Studio feature that we're talking about, we're really kind of breaking into a true visualization, a 3D representation of that business environment. So we started in just the kind of the data side, and now we're really showing off that being able to create an immersive view of what that world looks like, very easily for a lot of these cloud developers and even domain experts.
Okay, so you've got like a factory. So you have a machine in a factory, and then you've got like a temperature sensor and a vibration sensor and torque sensor. Then you would create a digital twin. So you'd have a virtual version of machine, and that machine would be virtually connected to the three sensors. So you could say, you could actually visualize that this machine has this temperature, this torque, this vibration in kind of the digital twins world. And then you're saying 3D scenes means you'd literally build a 3D version of that. And as if you're in like Minecraft or playing a game, you have like a 3D version of that, and you'll see the data on that the same as you see like the health bar in Minecraft. Is that basically what you're saying?
Think about like the operator persona in these factories who are trying to kind of understand their factory floor at a high level, understand each of the machines, and proactively recognize when a machine's about to need maintenance or requires any kind of attention. It's really great for these operators to see these in context views of these live data streams on top of the actual intelligent insights of that data, not just the straight up raw data. So creating this kind of view really allows the people who are most worried about those assets to react and even proactively act upon these machines before anything really kind of slows down and starts costing the business money.
So you kind of see the data, you see that this machine is vibrating more when it shouldn't. We can kind of make predictions on that, and we think that's going to break soon. So let's fix that machine now, rather than wait for it to break.
Exactly.
Awesome. Now all this kind of 3D stuff, I guess this kind of ties back to the metaverse. Excuse me. One of my favorite sessions from Build was Olivier Bloch talking about how IoT powers everything, including the metaverse. And he kind of talked about the metaverse. And I know something that Satya, during his keynote, he talked about the metaverse. Now, Olivier mentioned 3 types of metaverse: the consumer, the enterprise, and the industrial. So the consumer, that's kind of like gaming, isn't it? That's where you put on your one of these things and you kind of do your VR and your play.
That's what yeah.
The enterprise one is kind of where we would have a discussion like this, but we would be avatars. We'd have our virtual avatars be in like a virtual space. But the industrial, that's the exciting one. So, do either of you want to talk about what the industrial metaverse is and kind of how that applies to what you were saying, Riley, about 3D models of machines? Is it related?
Yeah, honestly, I think Alex has a lot of really good experience working with some customers in this space. I'd love to hear him speak about it.
Yeah, well, so the industrial metaverse is really interesting, as you said, Jim. It's taking, if we think about traditionally where we sit, where the industrial world is before, I mean, you used to have like data from HMIs, data that was in the factory. You would collect telemetry. Like the past 20 years in industry 4.0 and stuff has all been about collecting data, right? And it's been about collecting it, making sure you've got it historized, you put it on the edge, and that's been enough for people. But now with the industrial metaverse, we're kind of going the next step. It's like, well, let's take that data, let's now, for want of a better word, let's twin it, and let's take it and visualize that information, that data as information in a more a manner that's more easier to understand as human beings, right? We're not necessarily creatures that understand rows and tables. I mean, a lot of us are very intelligent and can probably live in rows and tables and spreadsheets and stuff, but actually when you think about the industrial metaverse, it's easier to infer relationships between things when you can see them. And obviously not necessarily physically, but you can experience them as near as damn it to physically, right? So you've got your 3D models of your machines. You can understand the state of that machine in the same way, almost in the same way that someone standing in the factory can understand the state of the machine on the factory floor. So, you've got be it a HoloLens or be it your VR headset, you've got it on, you can see the machine and you're almost seeing the same thing that the people on site in the factory are seeing, and you can understand the data and turn it into information that enables you to gives you actionable insights really on what's going on the machine. And 3D scenes, this really helps because we've had digital twins for a while, right? We've had Azure digital twins, we've had notional digital twins. I mean, if we think about things like flight simulator, right? That's a digital twin in effect of a simulated digital twin of the world with planes in it. But we're moving to a world where actually digital twins and the metaverse maybe it's going to become more ubiquitous. Things are going to exist twinned in the digital world, in the industrial metaverse, in the metaverse. So I think it's I can see that it's really exciting, and actually, as in the world of a developer, when I first started doing software development, there wasn't that. The only way you could interface with physical machines was before you had Raspberry Pis. You had to do low-level programming. PLCs, SCADAs, and the industrial metaverse, whilst you're not necessarily doing PLC and SCADA programming, you're doing representations of real world things. You're making representations of machines, factories and machines, space probes, cars, anything. If you think of anything that says it's a smart something, if you think of a smart TV, in effect, that's actually an IoT device. So in effect, that in theory could have a twin, which would be in a metaverse. It could be your interface into a metaverse if you think about it.
So I could create a twin of my house. Essentially, I could create the twin. I could take data from my smart TV, from my smart thermostat, my robot vacuum cleaner that's going off at the moment. All these things, I could take that data from that, twin that. So I've got this whole kind of representation of it. And as you've been saying, we've been doing this for years. We're capturing all this data, and then the whole picture paints 1,000 words. Rather than just having like a static chart, I could build this virtual representation of it. I could then, don my HoloLens, put this whole thing. I said on my HoloLens, I can't even work out if this thing works. Put this thing on my noggin. I could create a virtual representation of my house, sit it on my desk, and kind of see that live data. But I could do that. I mean, you could do that. So you could kind of monitor what's happening with the IoT device in my house from your house on the other side of the Atlantic Ocean by looking at that. And then because we've got 20 years of data, you could kind of rewind time, couldn't you? So you can actually go back and see what was my house like yesterday, the day before. And then with this data, if we plumb this in advanced machine learning models, we could actually then make predictions about the future. So we could see that, yes, based off, think of this in the context of my house, based off my daughter getting older, you can kind of see her usage of the internet is going up because she's doing more Minecraft. And you could predict that when she based off other data, you could build a model that reckons she's going to use this much internet because in her teenage years. We almost get this kind of slider through time and say, give me history, give me predictions, and just see that. I could sit that on my desk and kind of rotate it and play with it. Yeah. I mean, this is the kind of thing that Satya would show off in his keynote. And we look at these lovely images. It's usually this whole maintenance thing. You kind of see a technician putting this HoloLens on and kind of seeing these graphs appearing next to machines and kind of using that to fix it. It looks very sci-fi, but you're saying this is here now. This is what you're saying. 3D scenes is that really cool demo. It's here and it's now.
Yeah, this is what we're doing today. And the beautiful thing about all of it is it's really democratizing it for, of all levels of technical skills, of all localities. You don't have to be in that space to understand those insights. You don't have to be a data scientist. So yeah, all of those things, what we're really doing is making that feasible today. And, we're shipping it piece by piece here, but that's what you really start to see a lot of the building blocks and foundation for that being released and built on. And that's what I'm excited for Alex to show today a bit about what that looks like.
This is really cool because, as you say, we've always seen these funky demos, but we can actually do this. So I guess question for the audience, actually. Let's get some conversation going here. Have you done anything with digital twins, IoT, or the metaverse? I'd love to kind of hear what experience you've got. If you can get in the chat, we've just been bombarded with a whole load of cool opportunities to catch up on Microsoft Build and watch Top Gun Maverick. So the chat's full of all that. If you're in any of the areas we've got, you can join us for a build party and Top Gun, which is cool. I don't think we'll actually have any fighter jets in there, thank goodness. But we've got Top Gun Maverick and Build, which is pretty cool. But yeah, if you're in the chat, please let us know. Have you done any IoT work with digital twins, anything with the metaverse? We'd kind of love to hear what you've been doing and answer any of your questions. This is a conversation, so feel free to join in, ask us questions. We're here to help you. But Riley, you mentioned Alex has a cool demo. So Alex, do you want to actually dive into it? Should we actually play with some code to actually see how this works and kind of do a bit more of a deeper dive in this kind of, yes, we can do this. Can we see this in action?
Yeah. So we can see it in action. So one of the things I want to show you is one of the demos that exists. So if you go to explorer.digitaltwins.net/3D scenes, you've got access to if you've got Azure Digital Twins set up, you have access to 3D scenes by default. There's a demo. So there's a 3D demo which has a number of things like a factory. It's got wind turbines. It's got the International Space Station. Now, I actually have my own copy of the International Space Station twin with live data coming from it. So this isn't the demo, although the demo was built on this. So this component here, this 3D scenes, is actually built using a Microsoft open source React library called IoT Cardboard.js. That is available on NPM. So one of the things that Riley, myself, and the guys in the product team thought would be really useful, or I thought would be really useful from a selfish point of view, because I like playing with React and I want to put these things in my own React apps, was to have a create React app template. So when you do create React app TypeScript, right? It gives you a TypeScript React app with the React logo spinning around. It's not particularly, it's great for your first React app, but beyond that, it's not particularly interesting. We've built a create React app template, and I'm hoping to be able to demo it to you and get it up and running and show you. Create a React app with a 3D scene in it, and then build on those components. Because they're open source, you can actually interface with the 3D model. You can move the camera around with code. You can link to other systems if you want, or even Azure Data Explorer and show historical data, query the twin, do whatever you like. So
pretty cool. So this is literally a 3D model of the International Space Station with kind of data that simulates what will actually happen on the space station itself.
This is real data from the International Space Station. So one of my
real live data. This is what's happening now in the space station.
This is what's happening. I think the latency is around 11 seconds, but this is what's happening. So This is a 3D scene that I've already configured on top of. So we did an IoT show a few months ago with the International Space Station.
Mm-hmm.
This is built on top of that, and this is a 3D scene we built on top of that, which is what the standard open source demo is. So
literally, you're taking live data, you're visualizing that on here. So we're talking about how these demos that you see where you see the machine with numbers on it. This is literally that. This is literally a 3D model of the International Space Station. Currently, we're not showing it in the metaverse right now because we don't all have headsets on. But then we've got this is live data. You've got that panel there.
Mm-hmm.
This is bananas. Cool. This is great.
So it's pretty cool. So with 3D scenes and in Riley's demos, you can show single values, the current gauges, but it's actually a little bit cooler. So I want to just show one brief thing before we go into building the app. So you've got these behaviors, you've got the idea of twin aliases. If you think about the example you mentioned earlier, Jim, where you've got a machine and sensors hanging off of it, if we think about visualizing that, we'd actually have to visualize multiple twins, because quite often the way people model these things is they have the machine and then the sensors are separate twins in themselves. So we have this idea of twin aliases. So if we look in here, we've got a number of elements on the model, all of the solar panels, they're using a behavior. And if we look in the twin section, we've got a primary twin, which is each of the solar panels, and then the idea of twin aliases. These are the sensors that hang off of a solar panel, and we've got 4. We're saying there are 4 sensors that hang off a solar panel. If we go and click on this, we can see we've set up those multiple alias twins. So we're saying for solar panel 2B, twin P6005 is the current, and for this one, it's a different twin, and this one, and this one, and this one. So that's pretty cool and pretty useful. But what I want to show you,
like a 3D graph, of the different bits. So you've got these separate things, and you define these relationships between them.
Yeah, so you're just defining the relationships. But what's cooler is you're actually able to put your own, using those alias twins and the values on the twins, you can actually define your own expressions, so calculations, and render those as well. So we don't have the current power that a solar panel is providing on the twin, but we do have the current and the voltage, so we can calculate that at render time. So if we go back to the view, I discard those changes. If we click on this solar panel, that power is the result of a dynamic calculation based on the twins there.
Nice.
So you can, it's not just numbers. You could do, if you wanted to do a ternary command, you could do a ternary command that, if value less than this, then good, otherwise bad, or whatever. But what I want to do now is I'm going to take us through, I'm actually going to build a React app for us. So I'm going to go into terminal, our trusty terminal, which is here. And I'm going to do npx create React app. So npx, it's like npm, but a bit better. So from what I understand, we're actually able to, it'll go and download dependencies for us. So we don't have to go and install our template. It'll automatically download it from NPM. We're going to create a React app called Unpacking Build Demo using a template IoT Cardboard.js. So it's going to go and get that template from NPM. That's also open source as well, so we can go and look at code. So we run this. In the background, I'm going to show you, so you'll see it's downloading and installing the various, it's found the create React app template IoT Cardboard.js.
So quick question with that. So cardboard, that was the Google thing where you literally had a cardboard box that you'd put your phone in the cardboard box, and you'd use that to get like a 3D, basically a VR headset. Is this related to that?
I'm not sure, Riley. Do you know?
No, so, and that's I think what Alex was about to jump in there. So that is also a cool technology. But what we're talking about here is something that's actually kind of been incubated and created from the Microsoft side called IoT Cardboard.js. And this repository basically contains a lot of components that allow effectively kind of data visualization, especially as it relates to Azure Digital Twins. So here, all of the 3D scene studio that we've talked about today, so that builder experience, the viewer of a scene, all of those pieces are exist in this repository as React components to be npm installed and pulled into your own applications very easily. The core tenet of this 3D scenes idea for digital twins and even ADT, our Explorer applications and whatnot, are to be able to make these components easy to use up front and also very easy to bring into your own solutions, which is kind of what
right. Okay. So nothing to do with the cardboard headset. It's just kind of coincidence in the name. It's just here's a load of tools that just allow you to quickly deliver what you want to build. We kind of do a lot of the hard work for you.
Exactly, and make it very extensible in a lot of ways too.
Yeah, gotcha. Okay.
So what I'm going to do is I'm actually going to open. I'm going to open the directory that is generated. The React app has been generated in Visual Studio Code, and I will pop it on this screen.
Loving your color scheme in the terminal. I'm loving that rainbow color scheme you got going on the terminal there.
Yeah, when you see people like Scott Hanselman and stuff using it, you've got long videos about how to set it all up. I just went nuts with it one day.
If you can't have a cool terminal, what can you do?
No, well, exactly. I was like, I want to look like Scott Hanselman when he's using terminal. So the React app that's been generated, we can see here it's installed all the correct dependencies for us. Fluent UI, which is another Microsoft library for React components. You've got text boxes and stuff. You'll see there's a derivative of that I think Office uses. We've got Power BI client. We've got Microsoft IoT Cardboard.js. And then the only thing, it's a standard React app. The only thing that's slightly different, and we should probably acknowledge, is when we do the build, there's some slightly different commands here going on. So we're using React Rewired, so that we can use we can use React 17 with the Fluent UI components. And then we have this piece where we're doing node rename.js. Now, one of the problems or one of the challenges when you're developing against Azure Digital Twins is there's a challenge with cause. So if you go and try and connect directly to ADT, you'll get a cause error saying that you're not able to connect because you haven't got the correct headers or it doesn't allow your origin. So what we've done is we've got part of the build. So standard thing to do in local development is set up your own Proxy.js. This is all pre-configured for you. So there's a Proxy.js that will handle all the routing and the message handling for you. But then when you go to publish it, you need to also then do some stuff with proxy handling as well on top of that. So we have the server directory, and we've got the special rename.js, which once the build happens, it goes and puts the files in the correct location for publishing. That means that you won't have errors with cause. So it's nice. I would say it's kind of a workaround, but I know the product group is like on the roadmap to make that a more seamless experience. So as a developer, you don't have to do that. But in the meantime, what we've done is the Create React app is handling that for us, so we don't really have to worry.
Nice, because I'm not a web developer in the slightest. The very few times I do any kind of web stuff, I usually hit cause problems, and I have no idea what I'm doing. And you end up trying to, but I just go into this setting and static web apps, put a star in it, and hope it works. So having it all done for me, yeah, it's like, I don't know what I'm doing. I'm just a dev. I don't care. I just want it to work for my demo. So this kind of does that for me, so I don't have to worry about that. That's cool.
Yeah.
I like things that make my life easier.
Yeah.
So the other thing you end up with is this .m file. This is an important file which is going to help us with our React app, with our environment. So this is telling us where to point stuff. So the React app itself uses Azure Active Directory, as does all the other services. So what this does is it actually sets up the MSAL auth for you, as long as you've got your Azure Active app registration set up in the way that the generated README tells you to. So there's a README that you get generated as well.
So you have to actually set up as some kind of Azure Active Directory tenant on there.
Yeah, you've got to set up an app registration with the correct permissions. So you've got to have these permissions on it.
Because you don't want anyone to be able to access your data, is it? You want to have security. I know we joke that the S in IoT stands for security, but we work hard on security. So we don't want just people just accessing digital twin stage. It's not public; it is private to you. So that's cool. Nice.
Exactly. So this is designed. It doesn't work without you setting up your Active Directory stuff. But then what you need to do is you need to go and replace these settings in here. So you need your client ID, tenant ID, title, and stuff. So what I'm going to do is I'm going to close this and I'm going to do that off screen.
That kind of
with a
hush
file
hush
I prepared earlier. Let's see where it is.
All the secret stuff happening that we don't want people to see.
Yeah, there's secret stuff.
So this is setting up. You mentioned sort of storage there, so I guess there needs to be a storage account somewhere that actually stores the scene, because there's going to be some kind of 3D file that's got to live somewhere, because that's got to have the actual model that you'd see, and then all the configuration that you're setting up, that's got to live somewhere, doesn't it? So that's why you need to connect to storage.
Exactly. Yeah. Right. So you've got to connect to ADT, blob storage, and optionally Azure Data Explorer. So what I'm going to do now is I'm going to actually run the application and show you what we've got. So what do you get? So I've set my environment variables. I've told it to point at an Azure Active Directory application I've already built. So I'm going to bring up. This might take a minute or two to load.
Okay.
So rather than show you a blank screen, I can show you more of this. So the structure of the application is you get an app TSX out of the box. It's got some stuff to do with authentication. So we've got an MSAL auth service, which is using those environment variables. We have an application context, which has the auth service, a thing called an ADT 3D scene adapter. Now, the way we access the data in those cardboard components is via the use of things called adapters. So there's an ADT adapter, there's a blob storage adapter, I think there's an Azure Data Explorer adapter as well. And basically they have interfaces, so you could implement them yourself if you wanted, but there are some pre-canned ones that take, for example, the authentication service, the ADT host, and the blob URL. And those handle all the complexities of accessing the data for the twin for you and for the 3D scene. So you can literally plonk stuff in. So if we go to here, there we go, it's running now. So I will zoom in a tad. Oh, not on the globe. Take us up to 150. There we go. So we've got 4 tabs here. We've got one that's showing us just home, which is showing us a globe. So if you go into the twin ADT Explorer, the hosted one, this is the view you get if you switch to the globe view. You can put latitude, longitude on your scenes and locate them.
This is
We have a
using
twin.
like an example setup that's got the world on it as the model.
Yeah, it's just an example. We've got a twin builder,
Right.
twin viewer, sorry, which is showing us a twin that you've pre-configured. So in the environment variables, you can actually hard code a 3D scene to show. So we've got the twin builder here. This is running on localhost, but it's actually all using AAD to authenticate. So you'll see here, I've already signed in, so it's not
Right.
didn't prompt, but it would have had pop-ups to prompt me to log in. So you can see it's got my profile picture. It knows who I am. I've got access to this. We've got the twin builder, which is actually, this is what you see when you go to ADT Explorer. So it actually has a globe view in it, the list view. You can go into the scenes, you can build them and edit them. So this is all in the React app pre-configured. So you can do exactly the same things in this as you can do in ADT Explorer now. So we could go in here and forgive the styling. I've mucked up the styling somewhere in part of this, but you can go and do all the same things that you do in the ADT 3D scenes builder. Now,
all that the ISS, that's all provided as part of all this.
So the ISS isn't. This is just the scene I already have. So there is a repository from the previous. There's a repository from the ISS IoT show that has this in it, and actually will deploy all the stuff for this. But it's pre-3D scenes. We still need to we need to add the storage account to do the 3D scenes piece and the configuration. But there's a JSON config. So part of this, so this is all loaded from a configuration file in Blob Store. So what we can actually do is, I want to show you that configuration file briefly. So I'll bring this across here. So it's just JSON, right? So if you can load the JSON using the adapters,
So see, you've got a URL there to a GLB file, which is a 3D model file. So
exactly.
Right.
So, and it's just, this is in the Blob Store. So if you can access this using a blob adapter, you can show the, you can interrogate it. So I think what I'd like to do next, or what I want to show you is, we've got this application, right? But let's see how we can do some, let's see how we can do better stuff with it. So I'm going to take the application we've got here, and I'm going to drop a few files that I prepared earlier. And can you still see my screen okay?
Yep.
Yeah.
Yep. So what I'm going to do is I'm going to drop a few files that I prepared earlier into this scene, and then take you through the code in it. So we've got this.
So while Alex is doing that, I guess a question for the audience: who's an ISS fan? I know it's probably a silly question. I know we all are, but any space fans? Because this is a really cool demo for you, because you're visualizing real life data from the International Space Station, which is it's mind blowing, the fact that this data is not only available, but we can visualize this in a 3D model like this. So yes, in the chat, tell me, are you a space fan? Do you love the International Space Station? I know I do. I have it in Lego. Well, I say I do. My daughter has it in Lego. She's 9, but she's got Lego International Space Stations like this big. It's epic.
That's awesome.
So we can see this has changed quite a bit. It looks a bit, not rubbish, but it looks a bit messy, right? Because I'm a developer, I'm not a UX designer. So there's random buttons in places, and there's stuff down here. But basically,
saying earlier, he's focused on the UX. He's probably looking at this going, no, this is terrible.
This is awful.
Love the functionality.
So there's a number of things I wanted to show or demonstrate that we can do here. So we've got some buttons here. Now we can actually interact with the 3D scene itself. Now it's important to know that 3D scenes, or not important, but like 3D scenes is actually built on something called Babylon.js. So if you know Babylon.js, you can actually implement your own code to go and access do stuff on the model. So for example, lifted some code here that does some manipulates the camera given a Babylon scene camera given a scene, and given a radius, it will actually do an animation of moving. Basically between 2 points. So X, Y, Z, we can move the camera. So what I did in the twin viewer was, if we scroll down here, I created a preset list of camera positions, and you'll have to excuse this code because I did this all this morning as well. I've just been playing and seeing what I could do for the demo. But so I created this array of camera positions. I've created a wee function that's called move camera. And basically, when we click one of the buttons, so we've got a map loop around the camera positions. When you click that camera position button, which has the arrow, it's going to call the move camera, and that's going to actually interface with the 3D scene. I've called it baby scene because it's Babylon scene. It's going to interface with that Babylon scene. Now, how do we get the Babylon scene? Because if you think about it, that was a bit of a leap. So I've defined this method called handle scene loaded. When you create the 3D scene, so if we look down here, the 3D scene, the 3D viewer, the IoT cardboard JS element is just a component, a React component. And
so that actually renders that 3D scene.
Yeah.
Literally that block of code says, take this model I've defined in my config file and just render that on the screen.
Yeah.
That little bit of code. Nice.
That little this one line. So what I've got here is I've got some what I call scene view props, and I haven't got much in it, but you'll notice I've got my event handler. Basically, you can define things like what to do when the scene loads, when something's focused, when the mouse moves or the camera moves. All I'm interested in at the moment is the scene loading, and I've said, right, when the scene loads, store the scene as a variable that I can access and do other things with. So that's how we're doing the baby scene, move active camera using the baby scene. We've pulled the scene out of the context when it's loaded.
I now have Baby Shark going through my head. Baby scene.
That'd be awesome.
I guess for anyone watching who's not come across Babylon.js, it's like a 3D library, isn't it? In JavaScript, you can build games, 3D, 2D games, and just do cool 3D stuff. Is that correct?
Yeah, so it's a really incredible kind of rendering technology for 3D, and what's very useful for us here is it's very lightweight and extremely extensible. So though in these cases we're kind of just using the straight rendering capabilities, you can start to also take advantage of other kind of extensible points of it. For example, there's this thing called WebXR that allows you to take these Babylon rendered scenes and view them in HoloLens and other kind of similar technologies. So Babylon is really a lot of the firepower behind the entire kind of 3D scene studio, because it's just such a lightweight and easy to use kind of 3D rendering service.
Okay, so literally, I could use Babylon to build a 3D thing that I put it on a web page like Alex, you've got here, and I can spin it around. But then I could just take that, plumb that into this WebXR, and then I can stick this on my head, and I can actually spin the thing in 3D using all the things. So I had a question come through saying, I think Babylon.js can set AR flag to turn into MR app on HL2. So we can set an augmented reality flag to turn into a mixed reality app on the HoloLens 2. Is that still supported here?
So yeah, that's something that we've only recently released this thing, and we're kind of playing around with those extensibility points. So that's kind of our hope with all this stuff. But I think there's still probably some pieces to iron out when actually trying that. But yeah, that's really the core idea with 3D scenes here.
Yeah.
So essentially, because it's built on Babylon.js and you say it works with WebXR, it shouldn't be too much work for you to carry on extending this, so that I could then literally stick my HoloLens up on my noggin and have the International Space Station in my hand. So it's kind of this particular demo, we're almost there. So I know, Alex, for example, you did an IoT show where you actually had this. You actually had the International Space Station visible through HoloLens. That wasn't built using 3D Scenes Studio.
Yeah, it was before 3D Scenes Studio was invented. So it's actually built using the So on Azure Learn, there's a learning path which is like digital twins and mixed reality, and in it you end up with wind turbines on a piece of ground. We went through that learning path and then changed the models and changed the telemetry feeds in the back end architecture, and was like, well, let's use this and try and do the ISS. So the code for that is also in the ISS digital twins, getting started with digital twins repo, which I can put the link to in there.
Okay, I'm just grabbing a link for the build mixed reality with digital twins and Unity. The one you're talking about with it that uses the my brain's gone. Windmill.
Yeah, the windmills. Yeah,
windmill. Wind turbine. Sorry, wind turbine.
yes.
Windmill. Oh, it's early in the morning. And then I'm just going to try and grab a link to the IoT show with the ISS. Kind of show that one because that was a particularly cool. That was a particularly cool demo. The fact that you could build something like this and just have that. Just there is the Earth on the ground in front of me. There's the ISS, and kind of just watching it in 3D. This was pre the 3D Scene Studio, so probably have to do a bit more work to get that up. But it's pretty cool. And of course, now we're looking to do this with 3D Scene Studio. Kind of lowers that barrier to entry when we first start creating it to get our 2D one. And obviously, you're looking at now the future is going to be how we make that an extended reality thing going forward. Nice. So yeah, to answer your question, there is a flag, but we're not quite there with this particular demo. Oh, there we go. So I just shared a link to the IT show. I'm just grabbing a link to the
the core hope with 3D Scene Studio is, we have all these components. First of all, forkable, open source, but also even when you create a 3D scene in your own, Azure tenant, all of the 3D models and these 3D scenes configuration files are all available to you there. And the hope is that you can use our out of the box kind of visualization and whatnot. But there's plenty of other ways you can kind of view these 3D scenes, and we're hoping we're excited to see what the community learns and kind of tinkers with to be able to see their 3D scenes in novel ways, and if in kind of novel applications and devices and whatnot, as we are kind of working on those capabilities on our side as well.
Yeah, because you kind of don't want to say you can only do this with HoloLens 2 because that's $3,000 headset. You want to be able to say to people that yes, you can get your $300 Quest and use that, or do it on your phone using the various augmented reality technologies on iOS and Android. You want to have options for people. Because same as well, you go into a lot of places and they just have screens everywhere with dashboards. It's all 2D. So you want to be able to support 2D as well. Because it'd be a real shame if you had to do you had to spend $3,000 because that's prohibitive for quite a lot of people.
Definitely.
Yeah.
Nice.
So one of the other things we've got in this demo I wanted to show was that you can actually, so the config is JSON, right? So you can load it from the blob store and then interact with the models in your own way. So what I wanted to show was that blob store actually has multiple scenes in it for me. So if we go back to here, you'll see there's a 3D scene config.
Can you just zoom in a little bit on that one?
So we've got
you've got a config there. And those GLB files, those are, you can just create those with tools like Blender, can't you? The open source 3D tool.
Yeah, so you can just create them with Blender. The ISS one is actually publicly available on NASA's website, so you don't even need to do any modeling, just download it.
Nice.
So you can interact with that config file. So what I did here was I just created an accordion bar that has the scenes, and now we're able to switch because our scene ID is actually in state. We're actually able to switch between the scenes that we're rendering just by changing the scene ID. So if we go back to that, the code for the twin viewer, and we scroll right down here, you'll see that there is a scene ID. It's literally a GUID in that config file. So we're just switching between those GUIDs. But I thought that wasn't good enough. I actually want to zoom in on specific items. So actually, that config file has 3D elements in it and the mappings of those alias twins. So what I want to do is I'm going to switch to this city scene. There's a city scene. Cool, it's got some random properties on it. Those are actually properties from the ISS, but we'll pretend they're speeds or something. But then I want to quickly switch to the ISS scene specific component. I can click on that. It'll switch the scene and focus us on the correct component. It should do.
Nice. So you could set this up in like a factory where you had, say, 8 different machines, and you just list those machines down the side, and you just kind of quickly click between the different machines. It's not like you could only have one machine. You could have different machines, or even different factories. You could have
exactly. You could have different factories, different machines. You could have, models of the same thing, but showing, different models of the same thing showing different data. So you could switch from like an energy perspective to a production perspective and have different scenes. So that's just to show that you can still interface with this 3D model viewer, but you can also interrogate it and then control it based on user input. Which is
nice. So you're not just limited to, I've just got this view and this is all I can interact with. You've got the full code control.
Exactly.
So, one question I do have, I'm curious about this. I'm not a 3D modeler at all. Every time I've tried, it's been reasonably terrible. I can just about print a 3D print a few things to hold stuff under my desk. But so how does it know that that there is solar panel 2B, that is solar panel 3B? How do you have this link between the things on the 3D model and the actual thing that's being modeled by the digital twin?
Well, so that's a good question. So the twin builder, you have to do that. So at the moment, you have to do that manually. But basically, if we look at, is this what is going on? I'm not sure what's happened there. Basically, if we switch to the builder view in here, that's not behaving right. Obviously, some gremlins there. But basically, you upload your 3D model, right? And if it's one mesh, you're only going to be able to link it to one twin, right? But what you can do is, this model is actually quite high fidelity, so it's got lots of different components. You can select that component and say, this is an element I'm interested in, and then you choose the twin that you want to link it to. So, for example, this is the S3 truss, so I'm going to look for a twin. I've probably got a twin called S3. Yeah, I have got a twin in the ISS for that truss. So I can create the element. Now it knows that 3D model is linked to twin S3. So there's still a bit of curation there. But, you could, because it's a JSON config file, if you were in that way inclined as a developer, if you understood rules behind if you had specific rules on your 3D model about how your 3D model is made, say your CAD model, you could probably generate that config JSON so it had the mappings in it. So if I go and open this config JSON here, we'll see that there's in a scene, there is an array of elements, and it's a twin to object mapping. So you give it a display name, but it has that's the primary twin ID is the DT ID. And then that object ID is one or more meshes. So that's the ID in the 3D model of the mesh.
So you build a 3D model, and that's made up of all these different components, all these different meshes. And like you've got like the solar panel is just one mesh. And I guess when they probably created that mesh and then copied and pasted it, 8 times. Yeah. So each of those is a separate component inside the 3D model that's got a name. So it'd be like if you created, say you're doing like a person, you'd have like left arm, right arm, head, left leg, right leg. You kind of name those pieces. And then inside the Azure Digital Twins tool, so you can just literally click on that piece and say, this is what it's the twin of. And that tool you were showing, that is Azure Digital Twins Explorer. So this is this is the tool you use. This is the we provide. You just go in there, you upload a 3D model, and you just click on it and say it's this twin. So we do all the hardware.
But one of the key things I think to remember though is, unfortunately or fortunately, depending on how you look at it, the twins have to exist already. So you have to have created twins. But yes, you just say, right, I'm interested in this. Or you could say, actually, I'm interested in this, this, and this. This is, I don't know, this is node 3. Functional grouping of node 3, they are all this one thing. And now you can apply behaviors to all 3 of these things and sensors to all these 3 of these things. So if we think about the industrial metaverse, that could be a model of your factory. You could have all the machines on your production line. You could shift click them all and say, this is production line 1. And then have some behaviors or dashboards that sit above that production line and say what SKU is currently running, what's the current OEE of OLE of that line, for example.
Wow.
So that's
So
what
that
it
is.
enables you to do.
I'm sorry. This is just bananas. The fact that we've literally built this tool for you. So it's
Yeah.
not. I remember when digital twins were first started talking about it, you had to use the digital twin definition language and define the stuff in JSON, and it was all complicated. Now you're saying, no, we just literally launch this UI, drop in the model, define the twins up front, click, done. I always hesitate to use the word easy because things are only easy when you know how, but this feels like it's pretty easy. It feels like it's quite accessible. Once you've got the thing, the whole just clicky thing, you've got this 3D model with all the data assigned to it. You don't need to be a technologist. If say you're an operator and you understand the machines, you could come in here and say, well, I know that this is this one. I can click. You don't need to be a developer to actually set up this digital twin with this whole 3D scene studio.
Exactly.
That's mind-blowingly cool.
Yeah, when you think about the people who really know much about the actual business environments, the manufacturing line, knows what thresholds are worrisome for operators, whatnot. It's not really the cloud developers, the people who are writing the code. It's often the people who are on the ground, frontline workers. So this really just makes it a lot easier for the people who really understand the business logic to get this in there easy without too much friction, which is awesome.
Nice. Yeah, it almost feels like it's moving IoT into kind of the low code, no code world in some ways. Where the tools like Power Platform, which is designed for people to, if you're not a technologist, but you understand the business domain, you can still build an application. This is essentially part of that. Can you set up like rules? You're saying, Alex, that you want to see power, you can do voltage times current. So again, you'd have someone who understands the business side of it could build up those values of what they really want to see. Are there any kind of rules? Could they set up triggers to be alerted if something happens?
Yeah, so you can go. So then all of those pieces of functionality are grouped under something we call behaviors.
Right.
But basically, that behavior, you're saying, right, this thing has these behaviors. It acts in this way, right? So if we go and look at energy generation, right, I can set up the elements. I can actually add more elements if I want. I can look at other elements. But I can set what drives the status. So what actually drives the color of that 3D element. So we're actually using the power calculation again, and we're saying, right, when the result of this power calculation is between 0 and 3000, it's red. When it's 3000 to 5000, it's yellow. 5000 up, it's green. So the idea is that if you're a subject matter expert, you still kind of have to understand the expression language, but it's not. If we were to remove math.abs, that's pretty simple, and there is IntelliSense on that as well. So you could type times. There should be IntelliSense on this. It looks like there's maybe it's still early days, right? But there should be IntelliSense on that, so it suggests properties.
That looks no more advanced than what you do in Excel, pretty much.
Exactly. It's like if you think of it more like Excel formulas. So we've got status, then we've got alerts, which actually allow you to not change the color of the element, but actually enable you to pop up an icon above above whatever twin or element it's for. So for example, if we wanted, shall we take this power one, right? Now for some reason this power, we could say when it is, I'm going to put this icon when current times voltage is let's say greater than 1000, because it should be greater than 1000, but we're going to pretend that's an error state. So if I do that, update. Now we go to the view. In theory,
Checking that a refresh. Yeah, there you go.
yeah. But in theory, you should get alerts above the elements there, because we've updated the component and we're not getting any.
I guess we should draw attention to the word preview.
Preview, yeah. It's
that's the thing. This is kind of the bleeding edge. This is like hot off the presses. You know, we just announced this recently. This is in preview. This is your chance to play with it. So, I can see on you've got it there. You've got that little eye in red.
Yeah.
On the image tabs. It's not on the 3D view at the moment. It's just on the.
Yeah. So it should pop up over the solar panel for which it's there. So the idea is that if you're a subject matter expert, you're coming in to look at this. What you're interested in the industrial metaverse, or generally in anyone in their jobs, is when you open an application, you want to see what do I need to do now at the simplest level? What am I interested in? What do I have to take action now? So you can set up these alerts to help you dive into those things. Now, another thing to call out is the idea of these layers. So this thing Spartan, this solar panel array, I can't remember what the rest of it stands for, but it's solar, but it's basically energy, right? Now, the engineer is interested in solar panel and energy generation, isn't going to be interested in the current humidity inside the space station, or whether the airlock is engaged, right? So we have the ability to create these layers which can filter out these behaviors. So the subject matter expert who's interested in energy can just say, I only want to see the energy stuff. So I don't want to see ethos stuff. I only want to see my solar panels. So
again, about the idea of dashboards up on the wall, you'd have maybe one dashboard for solar panel, one dashboard for humidity, or let's just the energy crew would have just their energy one, and then a different crew in a different room would have the other one, and then maybe actually on the space station itself, you might have one with everything because they're in it. They're concerned about the whole lot. That's really nice. You're not just bombarded with too much information. That's really cool.
Yeah. So it's really nice, and because it's an open source component, you can have this in your own app.
So another question come through. So it'd be good if we can change the 3D object mesh size or position in addition to colors based on twin change for highlight effect. So it'd be really cool, I guess. Yeah, if something's a problem, blow it up really big so you can kind of see it.
Yeah, or even if we think of, well, in this example, it's the International Space Station, but these solar panels, right, they will orientate themselves. They actually stream the telemetry of the position. So updating the model to show how it is now physically, so moving the things, or if we think of like a smart car, having it positioned on a street in a city where it actually is based on telemetry, that's something I think Riley can talk to that a bit as well.
Yeah, 100%. The idea of that, the animation driven by data, absolutely. Like, there's so many different opportunities there, and I think that sizing is a kind of a novel concept there too. But I think that that's definitely the top of mind for the product team to go in that direction.
Okay, because as I say, this is a preview, so we're still iterating on this, and this is the time where we're gathering a lot of this feedback. So like I said, Alex, you want to have the solar panels moving, or if you have a delivery robot in the real world, you want to actually see where it is moving around a map, or even the ISS rotating across the globe. So that's something that's kind of top of mind for the crew. So as we do more and more of this, as we kind of go through and we head towards what we at Microsoft call GA, which is when we go from preview to public, these are the kind of features we're going to be thinking about, whether they'll make it in the first version or subsequent versions, but this is definitely top of mind. That's cool. Awesome. So we're practically at time. This is really cool. I mean, I love this stuff. I feel this is going to be one of the really big things. I certainly planning to focus quite a lot more on the industrial metaverse over the next few months, because I feel the technology now is ready. I know we talked about it in the past, and you watched Satya's demo 2 years ago, or his keynote 2 years ago, and you got the demo of the person with the HoloLens on, seeing the stuff. But it's here, it's now. We are now at the point where it's not a theoretical idea. It's, we've got the tools. we can start building this now. And this, to me, is hugely, hugely exciting. So Riley, Alex, thank you for helping unpacking the tech of Microsoft Build. This was a really cool session. I'm very excited by this tech. And thank you, everybody who joined us for this.
Thank you to our speakers, and thank you, everyone. If you have any feedback, we'd love to hear what you have to say. Please visit our survey which is on the screen, or I have posted in the chat. For the specific event, it's 16247. Thanks again. Until next time.
Thanks, everyone. Bye.
Thank you.